Hello and welcome to Code with Vinay. In this video, we'll explore whether the expression a equals a plus b is always interchangeable with a plus is equal to b or not. Many students think that the first statement in this problem, that is a equals a plus b, is simply a shorthand for the second, that is a plus is equal to b. But this isn't quite true. Specifically, we'll explore the case in which a equal to a plus b is not legal, but a plus is equal to b is legal. This is going to be a two-part video, and in the next video, we'll explore the opposite case. That is, a equals a plus b is legal, but a plus is equal to b is not legal. Both of these statements are assignment expressions. The first statement uses the assignment operator, whereas the second statement uses the compound assignment operator. The compound assignment operators are plus equal to, minus equal to, asterisk equal to, etc. According to the Java language specification, compound assignment expressions automatically cast the result of the computation they perform to the type of the variable on the left-hand side. If the type of the result is identical to the type of the variable, the cast has no effect. If, however, the type of the result is wider than that of the variable, the compound assignment operator performs the silent narrowing primitive conversion. Attempting to perform the equivalent simple assignment would generate a compilation error. To make this concrete, let us dive into some code. Now let us understand this with the help of an example. We have a normal case on the screen right now. We have an integer variable a which is assigned the value 0. We have another integer variable b which has been assigned the value 54321. And then we have our compound statement line a plus is equal to b. That is followed by the simple assignment line, but that is commented right now. And then we are simply displaying the value of a. So in this case, a is 0, b is 54321. Computer will first add 0 and 54321, and then the value will be stored in the variable a. So let us run this program for the sake of completeness. So we are getting 54321, nothing unusual over here. Now we'll verify the second case as well. So I'll comment the first line and uncomment the second line. Again, the same thing will happen. Computer will add 0 and 54321 and the value will be stored in a. Let us run this also for the sake of completeness. So here we are getting 54321. So these are the usual cases. This is how we think about the compound statement and the simple assignment. Now let us go back to the original case. Now let's have a look at the interesting case as well as the unusual case. So now what I'm going to do is I'm going to change the data type of the left-hand side variable, that is a, into something which is smaller than integer. So I'll go over here and I'll make this int into a short. Now notice what is happening. A plus is equal to b. The compound statement will first add integer 54321 to short a. The result will be integer 54321, but the data type on the left hand side is short. And the interesting part over here is that computer is going to automatically perform an automatic type conversion in case of a compound statement, meaning that the compound statement actually contains a hidden cast. If required, the casting is done automatically. But, and that's a very big but, and that is, this value 54321 is too big to be stored in the short. So an unexpected thing is about to happen. Let me run this program for you. So when I run this program, you'll notice that we are getting a negative answer, and that negative answer is coming because the computer is chopping off the two higher order bytes of the integer value, and we are getting a negative value. So this is something very important when using a compound statement, and that is, remember that there is a hidden cast. Computer will automatically typecast if required, and you might get an undesired value, like in this case we are getting a negative value. So but the case is still valid. Please understand, the case is valid, but If I comment the first case and I uncomment the second case, you will notice that the second case is no longer valid. Why? Because the simple assignment is not going to do any type conversion. There is no hidden cast involved in the second case. Hence, we see that if the variable on the left hand side is of a shorter data type or a smaller data type, the compound statement is legal, but the simple assignment case is illegal. The exact error which you will get in this case is type mismatch cannot convert from int to short. The moral of the story is that you should not use the compound assignment operator on variables of type byte, short, or char. When using compound assignment operators on variable of type int, ensure that the expression on the right hand side is not of type long, float, or double. Similarly, when using compound assignment operators on variables of type float, ensure that the expression on the left hand side is not of type double. These rules are sufficient to prevent the compiler from generating dangerous narrowing casts. Therefore, the conclusion is compound assignment operators silently generate a cast. If the type of the result of the computation is wider than that of the variable, the generated cast is a dangerous narrowing cast. Such casts can silently discard precision or magnitude. This brings us to the end of this video. See you in the next video, where we'll explore the opposite case, that is A is equal to A plus B is legal, but A plus is equal to B is not legal. Till then, happy coding. Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. You can follow me on the internet on any one or all of these channels.